Hello bachas, welcome back to the channel the F in Physics, where the F in Physics stands for fun. Now today we are going to look at a topic called potential divider. Okay, so if I break this term down, the first term potential means voltage. And we know voltage is the work done on charge to make it move through a component. It could be any component, it could be a bulb, it could be any other resistor, it could be your cell phone, it could be anything. And the next term over here is divider, which means this voltage is being divided or rather shared. Okay, why is this so? So let's assume you have a supply of 12 volt and you have a bulb that works on 3 volt. You obviously cannot do this because the bulb is going to blow off, which means I need to split this voltage into 3 volt and the remaining 9 volt. So that is where I will use another component which will take up the remaining 9 volts. And it's very obvious because the voltage is being shared, I will connect this component in series. Okay, so potential divider circuits is basically a fancy term given to series circuit. So what really happens? This is what you should know. In series circuit, your voltage is shared such that your voltage is proportional to resistance. We all know this, which means higher the resistance, more is the voltage taken. And therefore we conclude that because this resistor is taking up more voltage as compared to the bulb, the resistance of the resistor has to be greater than resistance of the bulb. Right? How much? Okay, so because voltage is proportional to resistance and my current is constant, I can say that this ratio, voltage of the resistor divided by voltage of the bulb, will be equal to the resistance of the resistor divided by resistance of the bulb. This is what you should know. Okay, we'll speak more about this in the further part, but this is the bare minimum that you should know to understand what exactly is a potential divider circuit. Okay, now we know what exactly is the meaning of the circuit, why it is used. Let's talk about the circuits that you can have for the exams. So this potential divider I can break into two parts. Okay, so my potential divider, I can have two types of circuit. Circuit 1, where the output is fixed. Okay, now over here you will not include any variable resistor. This will only have fixed resistors. Whilst type 2 can have variable output. Okay, over here I can use a variable resistor, or I can use a resistor that's made out of a semiconductor like a thermistor or an LDR, or I can use a POT, potentiometer, which you don't have in your syllabus. But what I can do is I can have a fixed resistor with a moving end, which means connected to a jockey. Okay, so this is what they will ask you. This normally comes in MCQs over here. This comes in structured. We'll see. Okay, so let's talk about the first type, where you have potential divider which is giving you fixed output. So obviously you need to have a power supply, and I have two resistors. You can have a bulb. Let's assume I need to control the voltage across a bulb rather, because if you understand, for a bulb it's very easy, you keep replacing the bulb. And this is capital V. This needs a voltage V1, that is the regular working voltage, normal working voltage. So the excess voltage goes here. The resistance of this bulb is R1, resistance of the resistor is R2. So from here I know that my current is same, like we mentioned before. My total voltage, because it is a series circuit, so assume UR charges, you are going to face resistance here, So you are going to lose some energy here, which is V1, and whilst you are passing through R2, again you will lose some energy, that is corresponding to V2. So the total voltage or the total energy that you need to pass through V1 and V2 becomes V1 plus V2. Because there is no branch, there is only one path with two resistors. You will have to overcome them. And I also know that because this is a circuit which has got fixed resistors or other ohmic conductors, my Ohm's law is obeyed. So for bulb, can I say my voltage across the bulb? V1 is the current flowing through it, because same current is flowing. Let the current flowing through the bulb and through the resistor be I. So V1 becomes I into resistance of the bulb. Common mistakes, what kids do is they take the total voltage for the bulb. That's where you go wrong. Remember, when you are using Ohm's law, it's V is equal to IR, very good, but remember that V is for a component, and if the V is for a component, you have to take a resistance of that component and the current flowing through that component. If you are looking for Ohm's law to be used across the circuit, the entire circuit, then your total voltage will be the total current flowing and the total resistance. Okay, this is where kids normally make mistakes, but anyway, chalo. So V1 becomes I times R1. This is for the bulb. And for the resistor, resistor का voltage कितना है? V2. So V2 becomes the current flowing through the resistor times the resistance of the resistor, which is R2. Equation 1, equation 2, if I divide 1 by 2, or if I divide the two equations, I get V1 equals I times R1 divided by V2 upon I times R2. You can cancel current, so you get V1 upon V2 is equal to, R1 upon R2. And this is what I had written above. This one. Okay. So whenever you have fixed resistors, remember the voltage is proportional to resistance. So this ratio is valid. There is one more formula that you can use. Okay, and the formula becomes voltage across V1 will be equal to the resistance across V1, which is R1 over total resistance, and the whole multiplied by the total voltage. Similarly, voltage across the second component will be the resistance of that component divided by the total resistance of the circuit multiplied by the total voltage of the supply. If there are 3 resistors in the denominator, you'll have to add one more resistance. And this makes sense. See, let's talk about this. This is no new formula. So I can write V1 equals R1, because it is multiplication. I can write the same as V upon R1 plus R2. Do you all agree? A upon B, the whole into C, can be written as A into C upon B, right? It's the same thing. Now, my lads, if you go back, look at equation 1. Okay, and look at equation 2. Can I say, beta, my total voltage is total current times total resistance. When you add them, that is what you get. Your total voltage is total current times total resistance. So your current becomes V over R1 plus R2, which means this term over here and this term over here is representing current, which tells us V1 equals I times R1, and that is what we have written here. Are you all understanding this? Okay, sir, ये वाला नहीं समझा. ठीक है, you can ignore this formula. But then remember this at least, because this is what you will need to solve questions where you have two fixed resistors. Okay, and from here I can say, beta, if my resistance 1 increases, obviously the voltage across V1 will increase, therefore voltage across V2 has to decrease. It's not that R2 will decrease, these are fixed resistors. Okay, so if I give you a question, ekdam simple question let chalo. So if I have a power supply and then I have a bulb which is 3 ohm, this is 6 ohm, and my voltage is 9 volt. We said V1 upon V2 is R1 upon R2, right? It's very clear that let this be R1, let this be R2. Since my R2 is more, V2 has to be larger. Correct? How do I solve this? Now to solve this, first you need the total current. So my total current becomes total voltage upon total resistance. Total voltage is 9, total resistance is 3 plus 6. Why? Because they are in series. So 9 upon 3 plus 6 becomes 1 ampere. This is my current. This current flowing through 6 ohm resistor will give you the voltage across the 6 ohm resistor, which comes out to be 6 volt. Same current flowing through the 3 ohm resistor will give you the voltage across the 3 ohm resistor. Okay. How, sir? We said V1 equals I times R1, which tells us current is 1 and resistance of R1 is 3, which gives me 3 volt. Similarly, V2 will be 6 volt. Another way of understanding this is we know that voltage is proportional to resistance, and my R2 is 2 times R1. So my V2 has to be 2 times V1. And you know V1 plus V2 has to be 9 volt. Now you just put V2 and V1. V2 is 2 times V1, right? So V1 plus 2 times V1 is 9 volt. 3 V1 corresponds to 9 volt. So V1 came out to be 3 volt. You will still end up getting the same answer. This is the best part about electricity. You know, there are so many ways of solving the same question. It's just that you need to practice. Keep your basics very strong. Okay. So this is using fixed resistors. In the next class, we will see what happens when you use variable resistors.